What's up? I'm Vin, and today I'm going through the January 2023 Algebra 2 Regents, and I'm doing parts 2, 3, and 4, but I'm starting off with part 2 where the questions are worth 2 credits. So question 25, we're going to algebraically determine the zeros of the function below. So we're going to set this whole thing equal to 0, and if we're going to find the zeros algebraically, we're going to use factoring by grouping. So what we're going to do here is find the GCF, or the greatest common factor of the first two terms, which would be 3x squared. And if we divide each thing by 3x squared, the first two terms, we're going to be left with x plus 4. And just know, if you want to check your work, you could always distribute it back, and it's going to bring you right back to where we started here. So now, next up, I would actually want to factor out a minus 3 instead of a plus 3. And I'm doing this strategically because if I divide each thing by negative 3, I'm going to be left with x plus 4. And the goal with factoring by grouping is to have a matching factor left on the inside with both. But remember, we're finding the zeros here, so make sure that you actually set this equal to 0. So now what we're going to do next is we're going to take out the common x plus 4. And if we take out a common x plus 4 like this, we're going to be left with 3x squared minus 3 on the inside like this. And we could set this equal to 0. So now we want to determine all the zeros here. So this could be broken down even further. Now, if you could do this in your head, then great. Otherwise, just show more steps here. So this I just kind of break down in my head. I say, okay, 3x squared minus 3 is going to be 3 times x squared minus 1. Make that a little bit neater. And then this actually is a difference of two squares, and we'll break down to x plus 1 times x minus 1. So if you could do that math in your head, then great. Otherwise, just show all your steps. There's no shame in it. So we're going to have x plus 4. And then what I'm going to write here for this next one, so this piece here, I'm going to write, remember, this is how we factor 3x squared minus 3. I'm actually going to write the 3 in front like this, and then I'm going to write our x plus 1 times x minus 1 like this. All right, and this is all equal to 0. So now what we have here is when we want to find the zeros, don't set 3 equal to 0. Like, just think about that. If you set each factor equal to 0, this is obviously not true. So you could just kind of ignore the constant here. But now you're setting x plus 4 equal to 0, you're setting x plus 1 equal to 0, and you're setting x minus 1 equal to 0. And this is going to give you a solution of x equals negative 4, x equals negative 1, and x equals positive 1. So you could just circle all three answers like this, or you could write it as one solution set like this, where we have negative 4, negative 1, positive 1. So here's our answer to question 25. So 26, we have given a is greater than 0. We want to solve this equation for x algebraically again. So we have to show all of our work here. So for this one, we want to know the power over root definition. So one thing that jumps out at me right away is that anytime I have an expression like this, if I have the c root of a to the b power, this is equal to a to the b over c. So it's power over root. So what I would do first here is I would write a to the x plus 1 is equal to a to the power 2 over the root is 3, because we're taking a cube root here. And then once you have two exponent expressions equal to each other that have the same base, you could just set the exponents equal. So this allows us to say that x plus 1 is going to be equal to 2/3. And then to solve for x, just do minus 1 on both sides. And you're going to have x equals 2/3 minus 1 is negative 1/3. If you have to use a calculator there, it's fine. Otherwise, the math I'm doing in my head is I'm calling this 3 over 3. When I subtract 2 minus 3 is negative 1. Keep the denominator the same. This is giving us our value of x. Question 27, we have the probability of a is equal to 1/3 and the probability of b is equal to 5 over 12. And we're told that a and b are independent events. And we want to find what is the probability of a and b occurring. So this is the symbol for and. And just know, because they're independent events means the probability of a and b occurring is equal to the probability of a times the probability of b. So then all we have to do here is just plug in for probability of a and b, and we're going to have 1 over 3 times 5 over 12. And we're multiplying fractions here, so we just do 1 times 5 is 5 over 3 times 12 is 36. So here's our solution to 27. Now, a little extra information, just know that two events are independent if the outcome of one does not change the probability of the other. So take a second to read through question 28. So there's this math test, and the scores are approximately normally distributed with a mean of 680 and a standard deviation of 120. And we need to determine the percentage of scores between 690 and 900 to the nearest percent. So what I'm imagining for this question is a normal curve here. So that looks like the bell shape here. And right at the center is the average. And the average here is 680. And then the standard deviation is 120. Let's make that a little bit neater. So 680 is our average. And then we're going up by 120. So if I add 120 here, that's going to put me forward one standard deviation, which would bring me to a score of 800. And then if I go 2 standard deviations, that would bring me up another 120, which would bring me to 920. So when we want to determine the percentage of scores, between 690 would be about here, and then 900 would be here. This is kind of like an awkward placement, which is why we're going to need the calculator to get this percent. So now what we do here is we're going to press second vars, and we're going to do normal CDF. That's number 2. And what we're going to do is we're going to have a lower limit here. And our lower limit is going to be 690. So we're going from 690 to 900. And then this first term here, so I'm pressing on, not 0. And now we go here. This is representing our average. Our average is 680. And then what we have next is our standard deviation. Our standard deviation is 120. So once you type in all the stuff that you need, all you have to do is just press enter, and the calculator is going to do all this work for you. The percent is going to be 43%, because notice here we have 0.43, and if we turn this to a percent, that would be 43.3, which rounds to 43%. Now, just in case you make a typo in the calculator, I would actually copy everything here. Now, the reason why I recommend you copying all of this is that way, in case you make some small mistake from here to the final answer, this will at least get you some partial credit. But we need to determine the percent, and we're writing our answer to the nearest percent. So this as a percent would be 43% if we round. So this is our solution. So question 29, we have data in this table, and we need to state an exponential regression equation to model these data, and we're rounding everything to the nearest thousandth. So we're just going to press stat, we're going to press enter for edit, and then we're going to enter the X in the L1 column, and we'll enter the Y values in the L2. So now once we have everything inputted here, we're going to press stat, go over to calculate, and then exponential regression is, we just go scrolling and looking for it, is option 0 here on this calculator. So we press enter and then just keep pressing enter a few times, and here's all the data we need. Now, same advice as before, I would actually copy everything that you have in the calculator onto your actual paper, so that way you get some partial credit just in case you make a small mistake. So A is equal to 2.45, and we're rounding to the nearest thousandths place. So then we're going to look at the 8, to the right is a 5, so we're going to bump that up to a 9. And then our B value here is going to be 1.61. And then we look at the 5, and then to the right is a 9, so we're going to bump that up to a 6. And now that we have all this, we could write our actual equation, which is going to be y equals a, which is 2.459, times, and I'll write b in parentheses, we have 1.616 to the x power. Question 30, we're writing this expression as a polynomial in standard form. So we have a of x times b of x first. So I'm going to write in a of x, that's x to the third plus 2x minus 1, and we're multiplying by b of x, and b of x is x squared plus 7. So this is the first part here, and then we have minus 3 times c of x. We have minus 3 times x to the 4 minus 5x like this. So now we just have to multiply this out. Just remember, we are multiplying before we subtract anything. We're using order of operations here. So we have x to the third times x squared first. So this is what we're going to multiply first. So we have x to the 5th, and then we distribute the x to the third to the 7, and we're going to get 7x to the third. And now we could distribute the 2x, and we multiply by x squared, we're going to get 2x to the third. And then distribute the 2x to the 7, we're going to get 14x. And then next, we're distributing the minus 1 to get minus x squared. And then minus 1 times 7 is going to give us minus 7. Now, these could be a bit tricky, but anytime I'm multiplying a 3-term polynomial by a 2-term polynomial, I know there's going to be 3 times 2 or 6 terms. Notice I have 1, 2, 3, 4, 5, 6 terms. So that's how I know I'm doing this correctly. And then next up, we're going to distribute over here. We got negative 3 times x to the 4 is minus 3x to the 4. And then we got minus 3 times minus 5x is plus 15x. So now we just have to be careful combining like terms. There's only one x to the 5 term, so we'll just rewrite it x to the 5th. And then next up, we have an x to the 4 term with a coefficient of minus 3. So we have minus 3x to the 4. But now we have some repeating terms here. We have a 7x to the third, and we have a 2x to the third. And when we add those, we're going to get a 9x to the third. So next in my list is the x squared terms. And it looks like there's only one x squared term. There's a minus x squared. So that's what I'm tacking on next. And then we have a 14x and a 15x. And if we add those, we're going to get 29x. And then finally here, we look for the constants. Let me just make that a little bit neater. So our 9 is going to be a little bit sharper. I'm going to rewrite it. And now we have our constant term here. It looks like there's only a lone -7 term like this. So our polynomial in standard form is over here. Question 31, we're going to completely factor this expression here. And I would define u to be equal to x squared, because then we make a substitution and we could rewrite this as u to the second power minus 5u plus 4. And now this is a little bit more familiar because we're looking for two numbers that have a sum of -5. And the two numbers also have to have a product of +4. And when we factor this, this is going to be equal to u minus 4 times u minus 1, because -4 plus -1 is -5. And the product of those two is +4. But then what we have to do from here is we have to substitute u equals x squared back in. And that's going to bring us to the next line over here, that this is going to be equal to x squared minus 4 times x squared minus 1. Now, one thing here, when they say completely factor, that's usually their polite way of saying, hey, if you stop here, you're not going to get partial credit. You're going to have to go further. So what we're going to have to do here is we're going to have to think of a squared minus b squared, which is equal to a plus b times a minus b. We have two difference of two squares situations going on. So this will factor to x plus 2 times x minus 2. The first difference of two squares, and then the second difference of two squares is going to factor to x plus 1 times x minus 1. Now just know, depending on your skill level of factoring, some people might prefer to just jump right from the question to this line here. But if you struggle to kind of see that algebra in your head, it doesn't hurt to define u as x squared. So question 32, Natalia's teacher has given her the following information about angle theta. Theta is between pi and 2 pi radians. And just know that pi radians is equal to 180 degrees. So they really gave Natalia a angle between 180 degrees, and 2 times 180 would be 360 degrees, which tells us here, if we think about the quadrants, 180 to 360 is going to be in quadrants 3 and 4. So then from here, we have to explain how Natalia can determine if tan theta is positive or negative. And we also have that cosine of theta is positive radical 3 over 4. So I mentioned this in the multiple choice earlier, but if you haven't seen that yet, then I'll mention it again. This is a very helpful thing to label in your quadrants here, ASTC. And this tells you that all the trig functions are positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. So if we're between 180 degrees and 360 degrees, right now that places us in quadrants 3 and 4. But cosine, notice radical 3 over 4 is greater than 0 or positive, which means that we're going to be in quadrant 4. Okay, because once again, we're limited to quadrants 3 and 4, but cosine is positive sends us here. So first we want to think about, how can Natalia determine if tangent theta is positive or negative? Well, these two pieces of information tell us that theta terminates in quadrant 4. So tan theta is negative because theta is a quadrant 4 angle. Now, one thing to really emphasize is that it's very important to mention the given information here, because that's what allows us to conclude that theta terminates in quadrant 4, which ultimately allows us to say that tangent theta is negative. So question 33, we're solving this equation algebraically, but let's say you can't do the algebra. If you use a calculator and you explain the steps, you could get 2 out of 4 points, which is better than 0. But if we want the full credit, we have to show the algebra. So that we're going to do by subtracting 5 on both sides, because we want to get the square root by itself. And then that's going to give us the square root of 49 minus 10x is equal to, and we're going to have 2x minus 5. So now to get the square root to disappear, we're going to square both sides like this. And one thing to be careful of, the left side is just going to become 49 minus 10x. But this side, you have to be careful. If you need to, you could go on a side quest and do 2x minus 5 times 2x minus 5. But if you could do this in your head, then great. We're going to have 2x times 2x is 4x squared. Then we have 2x times minus 5 is minus 10x. Then we have another minus 10x after we distribute this minus 5. And then minus 5 times minus 5 is plus 25. So this actually combines on the right side to 4x squared minus 20x plus 25. So that's what we're going to record in the next line here. We have 4x squared minus 20x, and then we've got plus 25. So our goal here, we have a quadratic, is to move everything to one side. And in this case, it's going to be easier to move the left side to the right side. So I'm going to go plus 10x on both sides, and I'm going to go minus 49 on both sides like this. So now this part here is going to cancel. We're going to have 0 equals, and we have 4x squared. We're going to have minus 10x, and then 25 minus 49 here. This is just going to be minus 24. And then what we have up next, I would probably want to divide out a constant here because I could do this by factoring, but everything here is even. Not everything is divisible by 4, but everything here is even. So I would divide each thing by 2. And that's just going to make life a little bit easier. So now we have 0 equals, we're going to have 2x squared minus 5x minus 12. And now I'm going to use the AC method here. So I'm looking for two numbers that have a product of, so this is our A, B, and C term here. So our A times C term is 2 times negative 12, which is negative 24. And our B term is going to be negative 5. And the mystery numbers that multiply to negative 24 and add up to negative 5 are going to be negative 8 and 3. So then in the next line here, we're going to write 0 equals 2x squared, and we're going to have minus 8x plus 3x minus 12. And now we factor by grouping. So this is going to break down to 2x times x minus 4 plus we take out a 3, we're going to have x minus 4. And now we could factor the x minus 4 out, and we're going to have a 2x plus 3 left over. So now for the next part here, we could just set each factor equal to 0. X minus 4 is equal to 0. Make that a little neater. And yep, let's fix up that equal sign. So we have x minus 4 is equal to 0. And we've got 2x plus 3 is equal to 0. Now this one's going to give us a solution of x equals 4. And this one, we're going to subtract 3 and then divide by 2. And this is going to give a solution of negative 3/2. But just know, if we stop here, we are stepping into a very dangerous bear trap. To get full credit, we have to check our solutions back to the original equation. So let's say I check out x equals 4 first. And that would give us, we would have 49 minus 10 times 4 is 40. And then we're going to tack on plus 5 equals 2 times 4 is equal to 8. And then this is going to give us the square root of 9, which is 3. And 3 plus 5 equals 8 is definitely true. So this is a solution. So now let's plug in x equals negative 3 over 2. So we're going to have the square root of 49. We have minus 10 times negative 3 over 2. And now we have plus 5 equals, we have 2 times negative 3 over 2. And now this is going to work out here. Let's see, we have the square root of 49. This is going to work out to 15 when we multiply these two. So we have 49 plus 15 is 64. And then plus 5 is equal to negative 3. And I can already see this is not going to work out because this is telling us that 8 plus 5 is equal to negative 3, which is not true. Okay, this is a false statement, which means we're going to reject x equals negative 3 over 2. And this is our only solution. So take a second to read through question 34. So Joette is playing this game and they're spinning a spinner and they want it to land on the number they guess. And she's complaining that the game is unfair because her favorite number is 2 and it has only been spun once in the 10 times she played the game. And first we have to state the proportion of 2s that were spun. Well, it has only been spun once out of the 10 times that she played the game. So here is the proportion of 2s that were spun. But next we have to state, what is the theoretical probability of spinning a 2? Well, assuming that this thing is fair, notice that the 2 makes up 1/5 of the entire spinning toy here. So there is a 1 out of 5 chance that anyone could spin a 2 here, assuming that this thing is fair. That's why it's the theoretical probability of spinning a 2. So question 34 continued. We have a simulation now that shows the results of simulating 10 spins of a fair spinner, and it was repeated 100 times. And we have, does the output indicate that the carnival game was unfair? We have to explain our answer. So looking at this here, remember the theoretical probability of getting a 2 was a 1 out of 5, which is the same thing. Remember, 1 out of 5 is the same thing as 0.20. So that's why this one is lighting up the most. But with Joette, she had the 2 show up 1/10 of the time. So this is kind of the column here we should be focusing on based on what Joette was complaining about. So let's actually take the time to count these dots. I didn't want you to sit there and listen to me count to 21, but I promise you there are 21 dots here. And what this tells us, since the simulation ran 100 times, that 21% of the time, the 2s showed up 1 out of 10 times. So this tells us that the carnival game was fair because 21% is not unusual. So the first order of business is typing this in the y equals. So I'm going to clear out the y1 spot, and we have -9, and we're multiplying by 3 to the power x minus 4. And then we're going to tack on the +2 outside the exponent like this. So I'm going to press zoom 6 just to make sure our graph is looking normal here. And now to make sure our graph is accurate, I'm going to press second graph and get a table here. But remember from before in the multiple choice, I messed around with the calculator settings. I'm going to press second window and make sure the independent is on auto. So that way when we go to the table, it has all the values that we're going to need here. But remember, when we actually make our graph, I'm only going to select values that give me whole numbers here. So if we scroll a little bit here, we could see that these central 3 values here are going to be the best. So now I could start by plotting these 3 points. Now, once we have these points plotted here, one thing to notice is that as we head all the way left in our table, notice that the y values are capping off at 2. So this is also heading towards the end behavior question. So what we have here is we actually have a horizontal asymptote at y equals 2. So I'm just going to draw this in here because when we actually make our graph, we want to make sure that we're approaching this dotted line, but we don't actually go through it here. Now remember, this is an exponential function, so when we connect these 3 points here and we aim at this asymptote, we should be thinking of an exponential curve. So now we describe the end behavior of c of x as x goes to positive infinity. So if you look all the way to the right, the graph is starting to drop. So that means that c of x is heading down towards minus infinity. So for the last part of this question, the horizontal asymptote is definitely affecting our end behavior here. It's acting almost as a ceiling. So as x goes to minus infinity, the c of x or y values are heading to 2, but not going to go past 2. So c of x is going to approach 2 as x goes to negative infinity. So question 36, we have the monthly high temperature in Buffalo, New York is modeled by this function. M is the number of the month. So January is 1, February would be 2, and so on. And we're finding the average rate of change in the monthly high temperature between June, which is M equals 6, and October. That month is the 10th month of the year. And we're rounding to the nearest hundredth. So we have to know the average rate of change formula. And when we're writing it in terms of this function, we're really going to be finding b of 10 minus b of 6 over 10 minus 6. So this is just the formula. But I'm going to actually write the units here because when we have to explain later, having the units is going to help us make sense of the question. So the monthly high temperature can be modeled by b of m. So the numerator, the b values here, b of 10, b of 6, are going to be in degrees Fahrenheit. And then 10 minus 6 represents the change in month. So our units for the bottom is going to be months. So we're going to have degrees Fahrenheit per month. Now, one thing here, we should make sure that we're in radians because we're typing in a trig function into the y equal spot here. So what we're going to do is we have 24.9 and then we have sine of 0.5 m, but we're going to use x instead. And then we have minus 2.05. And then we close this. And we're going to write plus 55.25 like this. Now, my advice, if you want to type this in accurately, you could just go and press second graph and scroll down to 10 and scroll down to 6 and see what is the y value here and copy out the long decimal and subtract and do all that. But there's a really slick way to do this on the main screen. If you press alpha y equals enter, when I want to write b of 10, remember I saved b of m in the y1 spot. So what I could do is I could go over to the numerator and I'm going to press vars. I'm going to go to the right to function. And y1 is where I saved my function and I'm evaluating it at 10. I'm going to write that in parentheses and close it. I'm going to subtract. B of 6 is going to be y1. So vars, go to the right to function, y1 of 6. I close the parentheses, and then I'm dividing by 10 minus 6. I'm going to pretend I don't know that 10 minus 6 is 4. And now I press enter, and it's going to do all the heavy lifting for us. So to the nearest hundredth, this is going to be negative 3.88 degrees Fahrenheit per month. So now we have to interpret this in the given context. So remember, this function told us the average high temperature in Buffalo, but we're going from June to October. So we're going from the summer to the fall months. So it makes sense that the temperatures are dropping. That's why our average rate of change came out negative. So we could say here that the temperature, the average high temperature each month is dropping at this rate from June to October. So we made it to part 4, the final boss, and this question is worth 6 credits. So we have this equation here for temperature, and we have Mark making t-shirts, and what I would do first is define all these variables. So he's removing a shirt from a press that makes t-shirts, and it heats the shirt up to an initial temperature of 400 degrees Fahrenheit. So our initial temperature, the moment the t-shirt is removed from the press, it's 400 degrees. So I'm just going to write the 400 without the units here. And then next here we have the rate that it cools is 0.0735. So that's our lowercase r value here. So we define this piece and we define this piece. And then next up here, what we have is the room temperature is 75 degrees Fahrenheit. So that's T sub r. T sub r is equal to 75. And then using this information, we need to write an equation for, we have the temperature of the shirt, capital T, after T minutes. So now we're ready to plug this stuff in. We have T equals, and then we have T naught minus TR. So we have 400 minus 75, and we have e to the negative, r is 0.0735. We tack on our lowercase t, and then we have plus T sub r was 75. So this we could take and we could simplify a bit. 400 minus 75 is 325. So we have 325e to the negative 0.0735. We tack on our lowercase t, and then we tack on our plus 75. So the next part here, we're going to use this equation to find the temperature of the shirt to the nearest degree after 5 minutes. So we're going to plug in t equals 5, lowercase t equals 5. And that's going to give us capital T equals 325 e to the negative 0.0735. And I'm replacing that lowercase t with a 5, but we're multiplying. And then I'm going to tack on our plus 75. So let's just type this in on the main screen here. We have 325, and e is going to be second ln to pull up e, and we have negative 0.0735, and we're multiplying by 5 here. And then we get out of the exponent and we tack on our plus 75, and we're rounding to the nearest degree, so this is going to work out to 300 degrees. So capital T is going to be 300 degrees Fahrenheit. So for the second part of this question, now we have Mark's friend Janine is removing a hoodie from the press, and that heats the hoodie up to 450 degrees Fahrenheit. So that's going to be the T sub 0 here. We have 450 like this. And then after 8 minutes, so that's lowercase t is equal to 8, we have the hoodie's temperature measures 270 degrees Fahrenheit. So that's capital T is equal to 270. And I borrowed this formula from the previous page here because we're going to need to plug into this in a moment. And then we have the room temperature is still 75 degrees Fahrenheit. So that's the temperature of the room is 75 degrees Fahrenheit. And we want to determine the rate of cooling of the hoodie. So that's lowercase r equals blank. That's what we're looking for. So this we just have to be careful plugging in. So we have 270 equals, and we have T naught, which is 450, minus T sub r is 75. And then we have e to the negative r times lowercase t is 8. And then we have plus the temperature of the room is still 75 degrees Fahrenheit. And now we can just clean this up a bit. This is 270 equals, and we're going to have 375 here, e to the negative 8r, and then plus 75. So now we could just do the algebra. We're going to have minus 75 on both sides. And from this point, though, they didn't say we have to solve this by hand. We could use a calculator at this step, but why not do the algebra? So what we have here, 270 minus 75 is going to be 195 equals 375 e to the negative 8 e to the negative 8r, and now we divide by 375. So from this step here, now we have 195 over 375 equals, and I'm going to leave a little space here, e to the negative 8r. And I'm leaving a space because to get rid of e, the opposite of e is natural log. So I'm going to take the natural log of both sides, and what that's going to do is it's going to cancel out the natural log and the e, and it's going to bring us to the next step here, which is going to be, and I'll start writing it over here, we have minus 8r equals ln of 195 over 375, and now to solve for r, just divide both sides by negative 8, and then we're going to be rounding our answer that we get from the calculator to the nearest 10,000th. So let's type this in. I'm going to press alpha y equals enter since we're typing in a fraction, and we have natural log of, we have 195 divided by 375, and we're dividing all of this by negative 8. So I just copy and pasted the value over here. To the nearest 10,000th means we're going to go out 4 decimal places. And if we look at the 7, to the right is a 4, so we're going to round down to r equals 0.08, and we have 17. And this is our solution to this part. So for the last part of this question, we have the t-shirt and hoodie were removed at the same time. We need to determine when the temperature will be the same to the nearest minute. So for this, we're going to borrow both equations from the previous parts. So I went ahead and just copied the formula from the first part of this question that we wrote down. And now for the hoodie, we just found what R is for the rate of cooling here for the hoodie. So now I'm just going to record that into a formula. So for our hoodie formula, what we're going to have here is we're going to have T equals, and remember, we got to this step here where we actually had to solve for R. But if we actually write the full formula out, remember, T naught was 450 minus T sub R was 75. So that would give us 375 e to the negative R, and R was, we had 0.0817, lowercase t gets tacked on, and then plus the temperature of the room was 75. Now to solve this, we're going to set these two equations equal to each other. So we have 325e to the negative 0.735t, and then we tack on our plus 75, and this is going to be equal to, we have 375e to the negative 0.0817t plus 75. Now right away what I notice is we could subtract 75 on both sides. So these are just going to cancel out. So the equation we actually want to solve here is going to be this one. But we already did all that algebra in the previous section here, so we might as well use a calculator for this round. If we did have to do this by hand though, we could. We would just have to natural log both sides, but the problem is, and I'm going to undo this in a moment, if I natural log both sides, I'm going to have to use properties of logs and split this up to ln of 325 plus ln of e to this power, and that's going to get very, very, very messy. So to avoid all of that, what would be better would be for us to just type this in the calculator. So to solve this out, let's type both of these in the y equal spot. Now let's say we graph this in standard mode. I'm going to press zoom 6 here. Notice that we don't see anything, so we have to go to the table, press second graph, and you could see here that if we look around, that at 0 we're at 325, 375. So the red graph is very clearly above the blue one, which we still can't see yet. But if we keep scrolling down here, you can see these numbers are pretty big. But by the time we get here, the red one is going to be under the blue one. So notice this takes at about x equals 20 for us to see that. So the first thing I would do is switch the x maximum out to 20 like this. But once again, I press graph, and I'm having a pretty hard time seeing of what's going on because once again, our values went way up to 400. So what I'll do is I'm going to go over to the y maximum and switch it to 400. Even though the max value here was 375, I'll go a little bit above. And now when I press graph here, you could very clearly see what's going on. And the intersection is happening somewhere in this space over here. So if I want to get a better idea of what's going on, what I could do, it's a nice little trick. I press zoom number 1. Even though you don't need to do this, but I just prefer to do this. I'm going to press enter. I'm going to go down and I'm going to go over, kind of like I'm cropping a photo. I'm going to press enter, and now the calculator is just going to graph this space here. So when I want the intersection, I press second trace number 5, and I'm going to go before and press enter, and I'm going to scroll after the intersection point, which we said was towards the end here. This is a safe bet that it's going to be towards the end, and press enter twice, press enter a third time, and here's our intersection. So to the nearest minute here, this is going to work out to t equals 17.45. We'll round down to 17 minutes. So we have t equals 17 minutes.